So in 9.3, we're going to talk about graphing rational functions. Now, a rational function is really a function, which is an equation in which the numerator and denominator both are polynomials. So we're going to have things like x plus 3 over x squared minus 9. We have some sort of x constant things in the tops and the bottoms. Now, a couple of things can happen with the graphs. We can end up with a hole in the graph, a value where the graph doesn't exist. We can end up with asymptotes. So a vertical asymptote happens here at -2. We can see that at the vertical line of x equals -2, both of the graphs come up to and close to, but never equal or cross over that asymptote. There also appears to be one here at y equals 0. Both of these graphs come up to and get close to, but never equal or cross y equals 0. These behaviors are largely dictated because of the denominator of a fraction. And we know that the number one thing that can never happen in the denominator is that it can never equal 0. And when it equals 0, it's undefined. We have holes, those values can't exist. There's no answer. And that's when these things happen to our graphs. So let's look at what happens. A hole or point of discontinuity, it discontinues, it's a break in the graph, occurs in the graph when there's a common factor in the top and the bottom. Okay, so we are going to cancel out some factor. The hole occurs at whatever coordinate causes the common factor to be 0. So that's how we're going to find the hole. That's the first thing. The second thing is a vertical asymptote. That is going to occur when the function is written in simplest form. Okay, so after we cancel, and we need to figure out when the denominator is 0. And that value that would make it 0 will be the vertical asymptote. Now the third thing is a horizontal asymptote, and that sometimes occurs and sometimes doesn't. And the main thing we have to do there is use a t-chart and go ahead and look at the behavior of our graph. So determine in these equations any vertical asymptotes or holes in the graph. So we have two things to look for. So first we're always going to factor. That is number one. We always have to factor. And so when I look at this numerator, that's the difference of perfect squares, so that's always going to factor into x plus 2 times x minus 2. This denominator, what factors of 6, will combine under plus plus to make 5, and that answer is 2 and 3. So remember, the holes in our graph are determined by common factors, and I have an x plus 2 and an x plus 2, so those are going to cancel out. So first we're going to talk about holes. So where will x plus 2 equal 0? When does that happen? That happens when x equals -2. And so somewhere on the graph at -2, there's a hole. Now we don't know where along that horizontal line there's going to be a hole. I'm going to talk about that next. But right now I know somewhere along that line of x equals -2 there's a hole. Now to go ahead and find the asymptotes, the vertical asymptote, remember we look at the simplified version, which is right here, of x minus 2 all over x plus 3, and we say, well, where would that denominator equal 0? So where would x plus 3, where would that equal 0? That's our little thought bubble. And that happens where x equals negative 3. So at the vertical line of x equals negative 3, there is an asymptote. So let's go ahead and factor this next one. This is going to factor into x plus 3 times x minus 3 all over, I have plus plus again. How do the factors of 15 combine to make 8? Well, obviously 3 and 5. So the first thing I'm going to look for are wholes. Do I have any common factors? I do. And so where would that common factor equal 0? That would happen where x equals negative 3. So again, somewhere along that line of x equals 3, there's going to be a hole. When I go to look for my vertical asymptotes now, I look at the simplified version, which is x minus 3 all over x plus 5, and say, well, where can't this, where doesn't this work? That doesn't work where that denominator equals 0. Where does that happen? That happens at x equals negative 5. So at x equals negative 5, there's a vertical asymptote. So here's our procedure. First, we're always going to factor. Okay, so once we have a factor, find the x values of any wholes, find the equations of any vertical asymptotes, find the y-intercept, if there is, find the x-intercept, make that t-chart for x and y values, and check both sides to see if it worked. Now I realized back here I forgot to actually find the coordinates of the x, the whole, the xy. So to find the coordinates, of the whole, okay, so where exactly is it? You let x equal negative 2 in this equation. So negative 2 minus 2 all over negative 2 plus 3. And so I'm going to get negative 4 over 1. And so that means my coordinate where the whole is at negative 2, negative 4. So now I know exactly where it is. Same thing happens over here. I let x equals negative 3 in this simple form to get the coordinate. So where is that coordinate of the whole? Well, it's at negative 3 minus 3 all over negative 3 plus 5. So I end up with negative 6 over 2, which is negative 3. So the coordinate of my whole is at negative 3, negative 3. Now, to go back to this problem. So first of all, do I have any common, is this factored? Yes. Do I have any common factors? No. So I'm done with that step. Vertical asymptotes. Remember, vertical asymptotes happen where the denominator equals 0. So I have a vertical asymptote at x equals negative 1. So along this vertical line of x equals negative 1, my graph is undefined, because if I put negative 1 into this function, I get 0 in the denominator and it doesn't work. So now to find my intercepts. If I let y equal 0, if I let, let's say, x equals 0, first of all, I get 0 over 0 plus 1, which means that's going to be my y value, which means y is 0. So this thing crosses at 0, 0, which is both my x and y intercepts. If it were a different value, you would have to go ahead and solve for the other one. Now, I have to test what's going to happen on this side and see the behavior, and then I have to go over here on this side and see the behavior. So in my t-chart, if this is x, this is my y, which is x over x plus 1. And I'm going to go ahead, and if I put negative 6 in here, I get negative 6 all over negative 6 plus 1, which is 6 over 5. So at negative 6, I have something just over 1. If I put negative 4 in here, I have negative 4 over negative 4 plus 1, which is 4 over 3. So if I go over to 4, I'm just over 1. If I put negative 2 in, I have negative 2 over negative 2 plus 1, which is going to be 2 over 1. So at negative 2, it's 2. And so we know, because there's an asymptote, that this is going to take off like that. And the interesting thing that seems to be happening over on this side is seems to be that it's going to get close to but never cross y equals 1. So let's go over on the other side and test some values on the other side of the asymptote. So let's put in 1. And so I have 1 over 1 plus 1, which is 1 half. So at 1, I have 1 half. Let's put in 2. I have 2 over 2 plus 1, which is 2 thirds. If I put in 4, I have 4 over 4 plus 1, which is 4 fifths. And while I'm getting bigger, I'm not getting bigger very quickly. And so I know that this graph is going to go asymptotic out y equals 1 and x equals negative 1. And this shape is a hyperbola. And it always exists in opposite quadrants. So here 2 and 4, or 1 and 2. So let's try another example. First we have to factor, and this is going to factor into x plus 4 times x plus 1 all over x plus 4. Here I do have common factors, so that means I do have a whole, and that whole is at where that common factor, where does that equal 0? It's going to be at x equals negative 4. To find the y coordinate of it, I go into the simplified form, and so I have negative 4 plus 1, which is negative 3. So my whole is at negative 4, negative 3. Negative 4, negative 3. There's a hole in my graph. Now when I look at what's left, my simplified form is x plus 1. There's no denominator, so that means there's no vertical asymptote. And since this equals f of x, I know that it equaling f of x is really like saying it equals 1. This looks a whole lot like slope-intercept, which means I can plot a point at 1 for my y-intercept. My slope is 1 over 1. And I can draw my line, remembering to leave a gap at negative 4, 3. Now you could go ahead and do your t-chart if you don't see that it's a linear graph, but it will work out the same.